Right, recording has started. Made it to a Friday. Oh, it's Friday 7th period, so we're about a half hour from another weekend. You guys just turned in your chapter 14, 15 puzzles. Looks like this page here. And then, of course, you guys have this quiz with a tuning fork on it due Monday. Double check all these problems. We're going over all those. So you go back and check the videos on any of those, and those are there. All right. A couple weeks back, I read you guys some science articles, and then thinking this week what I wanted to do with today. Actually, I like that activity, so we'll do that again. I went to Reddit last night and found some pretty good ones that uploaded that I thought you guys would be interested in. So this class period, if you want to just sit here and hear me listen to me read these science articles to you guys, then you can do that. Tell you what, too, if you want to sit there and knock out this quiz so you don't have to think about it over the weekend, that could be a good use of your time today. I want to do that. And so let me lead through these first real fast, read the headlines so you know some articles I found, and then we'll go back through and read them in more detail. We got Tonga volcano eruption creates puzzling ripples in Earth's atmosphere. Ooh, look at that. Got this satellite image. Actually, let me flip here. This is actually pertinent to what we've been studying the last couple of weeks in this class. Okay, so for context, this satellite image, you guys see the coast of Australia. Here's Papua New Guinea. Here's New Zealand. Ooh, these are huge ripples. This huge volcanic explosion. It actually created patterns that scientists have never seen before. So hang tight on that one. We've got owl wing design reduces aircraft and wind turbine noise pollution. So if you've ever been next to helicopter, drone, plane, a lot of the noise that comes off those is just air moving over the wings. But some animals in nature, like owls, super silent. So there's this idea that engineers can draw ideas from nature. I mean, and incorporate those into designs. One classic example is Velcro. So if you look at like those stickers that like stick to your socks, say if you walk through grass, that was actually an inspiration for modern Velcro design. You just make a plastic version of that basically. So article on that, got some more stuff to say about that, but we'll get there. Disinfectant made from sawdust mows down deadly microbes. Turns out, I'd never known this, that wood and sawdust has antimicrobial properties. Like, who would have guessed? So fun story there. We got Antarctica's Thwaites Glacier ice shelf could collapse within 5 years. This is a big one. It's about the size of Florida. And how much is sea level going to rise from this? Well, stay tuned because it's in this article. It's quite a bit. I think I'm pronouncing that right, but I don't know for sure because I just read it. I don't know if I've heard it pronounced. Am I saying that right? Does anybody know? Thwaites. Is that right? Thwaites. It's okay. Probably. All right. I don't know. Sometimes it's like weird pronunciation. Maybe you guys know. A simple retina scan could predict your risk of early death. They could read off the back of your eyeball. It could be a pretty telling indication of how old you are, and sometimes that may not exactly match your chronological age. We got chemical pollution has passed safe limit for humanity, say scientists. Right. Now, this one I haven't read thoroughly and haven't got to in any of my classes today just because limited time, but I'm sure they quantify that somewhere. I see some numbers here. Do you guys know that in the history of planet Earth, there have been in the past 5 mass extinctions? One you guys probably know for sure is the one that wiped out the dinosaurs. That was the last one that happened about 65 or so million years ago. We're actually in the middle of the 6th mass extinction right now. And you can know that by looking at rate of species extinction. So yeah, new species emerge over time, over millions of years, and species die out over millions of years, but it's usually like a gradual type process. But there are certain like mass extinction events, right? Asteroid hits, all the dinosaurs die. And the rate of species extinction right now is it's on par that we are like in the middle of a mass extinction event that's almost certainly caused by anthropological forces, right? Human activity. Antibiotic resistance killed more people than malaria or AIDS in 2019. A couple weeks back, had another one similar to this antibiotic resistance there are some bacteria now that are resistant to anything that we have. We can't treat it. Well, I guess we got wood shavings now, but I don't know the exact statistic. I can't remember this, but malaria. So over the history, like the entire human history, there have been approximately 100 billion people who have lived on Earth. Like you count like all the people that have ever lived. And some crazy fraction, I can't remember the crazy fraction of people have actually died of malaria. So yeah, now we got this antibiotic resistance is killing more people than that. So yeah, look for that in the future. It'd be like just like a super pandemic of bacteria in the future. Sleep habits and susceptibility to common cold. Right, so I'm almost certainly not going to have time to get to this one today, so I'll just summarize it for you now. And also, you guys see this is actual snippet from an actual journal paper. All those other ones are science articles. This is actual journal paper. So, in summary, if you get 7 hours or fewer, 7 or fewer hours of sleep every night, that's not enough sleep according to this. And if you get 8 hours, that's like a proper amount. So 7 or fewer hours, you're actually about 3 times as likely to catch the cold as if you get the full 8 hours. Now, if you're thinking scientifically, you might think, well, maybe there's some third variable that's not in that story. For example, if you're awake that extra hour, maybe that's an extra hour that you go spend with people. And if you're spending it with people, maybe you're catching a common cold that way. No, they actually controlled for that. So this has everything to do with your immune system. So if you get properly, like enough sleep, that's actually beneficial to your immune system health. All right, let's go back to the beginning and read details of these. So you guys got a real broad overview. So back to this Tonga volcano, creates puzzling ripples in Earth's atmosphere. Powerful ringing through the atmosphere after the eruption of Hunga Tonga Hunga Ha'apai are unlike anything seen before. Scientists are racing to understand the puzzling series of massive ripples in Earth's atmosphere triggered by eruption of Tongan volcano over the weekend. Satellite data shows that the event, which some fear may have devastated the Pacific island nation, provoked an unusual pattern of atmospheric gravity waves. Previous volcanic eruptions have not produced such a signal, leaving experts stumped. It's really unique. We have never seen anything like this in the data before, says Lars Hoffman, an atmospheric scientist at the Jülich Supercomputing Center in Germany. Discovery was made in images collected by atmospheric infrared sounder, AIRS, mounted on NASA's Aqua satellite in the hours after the eruption of Hunga Tonga Hunga Ha'apai volcano on January 14. They show dozens of concentric circles, each representing a fast-moving wave in the gases of the atmosphere stretching more than 16,000 kilometers. I want to say from Florida to New York is approximately 5,000 kilometers, I think. So maybe like 3 times that distance. I mean, you can see it on this map how big this is. Yeah, here's coast of Australia, here's New Zealand, Papua New Guinea, and here's blue, the circle. They show dozens of concentric circles. Okay, here. The waves reached from the ocean surface to the ionosphere. That's like the upper layer of the atmosphere. And researchers think they probably passed around the globe several times. So if you have the correct detection equipment, probably you could get a signal even here in Florida on the opposite side of the Earth. Nice concentric wave patterns. The instrument has been operating for something like 20 years now, and we've never seen such nice concentric wave patterns, Hoffman adds. Atmospheric gravity waves occur when air molecules in the atmosphere are vertically rather than horizontally disturbed in the air column. This can happen when wind picks up speed as it rises over a mountaintop or as a result of convection and local weather systems. The up and down waves transfer energy and momentum through the atmosphere and often show their effects in ways which they cause high clouds to form in a series of ripples. Images from atmospheric infrared sounder on NASA's Aqua satellite show dozens of concentric circles, which are fast-moving atmospheric waves. In theory, the rapid updraft of hot air and ash from an erupting volcano in the upper atmosphere could trigger gravity waves on a much larger scale, but nothing like this has been observed with previous eruptions analyzed since the AIRS instrument was launched in 2002. Oh, side note here, you know what this kind of reminds me of? You guys have heard of Krakatoa? Krakatoa? This was a really famous volcanic explosion back in 1883. So pulled up a Wikipedia page I'm reading right in front of me now. It says that that explosion was 180 decibels. Woo! Keep in mind, remember, threshold of pain. I told you guys before in the notes it's about 120 decibels. On this page, it's saying 134. So somewhere in there, you guys know something like a power of 10, like 100 something decibels. Uh, that in this like 120, 130 decibels, that will like physically tear your eardrums apart. You become permanently deaf. Krakatoa back in 1883 was 180 decibels. So if you were anywhere in the vicinity, you would have been blown deaf, and that produced shock waves that also traveled around the world. So continuing with the article, that's what's really puzzling us, says Corwin Wright, an atmospheric physicist at University of Bath, UK. It must have something to do with the physics of what's going on, but we don't know what yet, why these ripple patterns are showing up. He and his coworkers suspect that a great big messy pile of hot gases in the upper atmospheres might be what kicks the waves off. The hot gas is going up high into the stratosphere and knocking the air around. So eruption heard around the planet, and explosive speed. This goes on a little bit more, a few more paragraphs, but okay. So fun story there. If you want to read more about it, then sure you can shock the internet for volcanoes. Owl wing design reduces aircraft and wind turbine noise pollution. Washington, January 18, 2022. Trailing edge noise is the dominant source of sound from aeronautical and turbine engines like those of airplanes, drones, and wind turbines. I'll tell you guys what too. How many guys have seen a wind turbine? Seen a wind turbine in life? 3 guys? Because I know in Florida we don't. I don't know if I've seen one really in Florida, but yeah, out in the Midwest. I know they kind of nearby them, and they didn't really seem noisy when I was there, but I don't know, maybe for a run long time. Suppressing this noise pollution is a major environmental goal in some, it says some urban areas. I mean, I'm sure it's true, but I think it's more just true in general too. I say after 9/11, when all the planes were grounded for a couple of days and a bunch of cargo ships were paused for a few days, scientists who were just studying whales noticed that whales were releasing fewer stress hormones. So it's like the whales were less stressed out. Now there were fewer planes flying overhead and fewer cargo ships going across the ocean. So yeah, there's a lot of things that humans do that we probably just don't even realize the environmental impact that we're having. So this is OWL. And Physics of Fluids by AIP Publishing, researchers from Jiao Tong University used the characteristics of owl wings to inform airfoil design and significantly reduce the trailing edge noise. Nocturnal owls produce about 18 decibels less noise than other birds of similar flight speeds due to their unique wing configuration, says author Xiaoming Liu. 18 decibels. You guys have a quiz question that involves a change of 20 decibels, which is almost that, isn't it? Hey, let's do a little math right here. I wonder what the intensity difference is between, say, this owl versus other birds. 18 decibels, right? You guys know decibels refers to some power of 10. So let's do a calculation here. It's 10 to the power of number of bells. Wouldn't this be like 1.8 bells? Right? And on your guys' quiz that you guys are going to turn in a few days, you have 20 decibels. That's like 2 bells, right? Difference. Because if you take the difference of number of decibels, right, that difference corresponds to some like ratio difference in intensity. Right, so what's 10 to the power of 1.8 bells? I'm looking at a factor of 63. And if you do something very similar on your quiz, then you'll get the quiz answer. Right? So this owl is 63 times quieter than other birds in terms of intensity, right? Moreover, when the owl catches prey, the shape of the wings also constantly is also constantly changing. Ooh. So the study of wing edge configuration during owl flight is of great significance. Yeah, keep in mind that how this process might work. Like engineers trying to steal designs from nature. I mentioned Velcro as an example. Well, how would an owl be so quiet? how is its wings so quiet when engineers can't even figure out how to crack this problem? Uh, this is a process of evolution over millions of years. Let's say you go back like 5 million years ago. There's probably either owls or some owl-like creature millions of years ago. And maybe some had slightly louder wings and some had slightly quieter wings. Just a complete fluke of their DNA. Nobody chooses their DNA, right? And then over time, the quieter owls are better hunters, catch more food, more likely to pass on their genes. So this iteration process of evolution over millions of years, like naturally delivers really good solutions to problems like having quiet flight wings. At present, the blade design of rotating turbo machinery has gradually matured, but the noise reduction technology is still at a bottleneck, said Liu. Engineers are still struggling over this problem. The noise reduction capabilities of conventional sawtooth structures are limited, and some new non-smooth trailing edge structures need to be proposed to develop to further tap the potential of bionic noise reduction. Sawtooth structure, that's like, that looks a lot like wings, wouldn't it? That sawtooth type structure. Yeah, that's why they're looking at that. The team used noise calculation and analysis software to conduct a series of detailed theoretical studies of simplified airfoils with characteristics reminiscent of owl wings. They applied their findings to suppress noise of rotating machinery, things like wind turbines, improving the flow conditions around trailing edge and optimizing the shape of the edge suppress the noise. Interestingly, asymmetric serrations, reduce the noise more than their symmetric counterparts. Who would have thought? Who would have known by having an asymmetric design that actually was a better design in terms of sound than a symmetrical one? Noise reduction varied with differing operating conditions, so scientists emphasize that the airfoil designs should be further evaluated based on the specific application. Okay, so maybe if you have like a plane versus a helicopter versus like a wind turbine, maybe there's like different solutions to those different scenarios. For example, wind turbines have a complex incoming flow environments which require more general noise reduction technology, right? Because and the wind turbine is kind of like stuck in orientation, but maybe the wind blows at different angles over course of time. So how could you feel all those different conditions? Examining noise reduction techniques under the influence of different incoming flows would make their conclusions more universal. The researchers believe their work will serve as an important guide for airfoil designs and noise control. Right. So looking to nature for engineering solutions, in this case, reduction of noise for flying objects. A disinfectant made from sawdust mows down deadly microbes. Wood waste could help make some cleaning products more sustainable. Since I pulled these off Reddit too, for some of these articles, I actually copy pasted one of the top Reddit comments, and this one I liked a lot. I thought was pretty insightful and interesting. Says, so this is just some guy commenting about the article. He says, I was a butcher for 35 years. We used to have these wooden block tables and spread sawdust on the floor. Now imagine this, right? So you're sitting here like chopping meat all day on these wooden tables. There's probably little bits of meat and sawdust getting spread all over the floor. It sounds pretty bad, right? Well, the health department would have agreed with you because it says right here, the health departments around North America all decided that that was unhygienic. Sounds about right. And decided that we needed to switch from wood to nylon boards to get rid of the sawdust, right? So health departments come in and say, hey, switch from wood to plastic. Well, it was found out shortly after that the wood had been killing all the germs and that those plastic nylon boards got small cuts that harbored bacteria. Oops. A new sustainable disinfectant made from sawdust and water can knock out more than 99% of some disease-causing microbes, including anthrax and several strains of flu. Widespread use of some disinfectants can cause environmental harms. Like think if you use some cleaner at home, what could you use? For instance, chlorine-containing ones, such as bleach, can form dangerous byproducts when they react with other molecules. Some other potentially greener disinfectants, say like more environmentally friendly ones, rely on a compound called phenol or its chemical lookalikes but they can be costly and energy intensive to make. Phenolic structures abound in wood, however, as part of the large branching molecules that make up plant cell walls. Ooh. So environmental engineer Xicheng Zhang of Fudan University in Shanghai and colleagues wondered if sawdust waste could provide a greener source of antimicrobial compounds. The researchers cooked mixtures of water and sawdust for an hour under pressure and filtered them. Then the team tested the sawdust concoctions for their prowess at killing off the microbes, Staphylococcus epidermis, I think. I'm sure I'm mispronouncing some of these names. A skin microbe that can cause infections in immunocompromised people, and E. coli, a gut microbe that can cause foodborne illness. Depending on the disinfectant's concentration, it could zap more than 99% of microbes, the team reports in Proceedings of National Academy of Sciences. The disinfectant was similarly successful at inactivating anthrax and influenza viruses, the researchers found. It may be also be potent against spores, a dormant form of bacteria that can be difficult to kill. Experiments showed it could inactivate the spores of typically harmless bacteria, Bacillus subtilis. A chemical analysis revealed that sawdust-based soup contains high concentrations of phenol-like compounds. The pressure cooker treatment probably breaks off the wood's molecular chain, bringing up antimicrobial phenolic molecules. Under a microscope, scientists saw that their disinfectant damaged the cell walls of E. coli and S. epidermis. The phenolic compounds may also damage the proteins and genetic material of bacteria and viruses, Zhang says. All right, there you go. Yeah, so wood, sawdust actually has antimicrobial properties. Again, since it comes from nature, this has been millions of years evolutionary battle probably between wood and bacteria. It's probably a pretty good sustainable one. And just in time as first this other article, as we're running into problems like this, antibiotic resistance, maybe there's a new solution in wood. Antarctica's Thwaites Glacier ice shelf could collapse within 5 years. The loss of its buttressing ice shelf could hasten the demise of this doomsday glacier. Catchy name, Brian. Quick geography synopsis of Antarctica. Even though it looks like a single solid ice sheet, well, kind of is, there's an eastern half and a western half. The eastern part of Antarctica actually is a land mass covered in ice, but the western part, and that's where this glacier is, the western part, actually that ice shelf sits on top of an archipelago. So there's all these little dots of islands, there's the ocean underneath it. And as that ocean water warms up, say like, half a degree Celsius, 1 degree Celsius, well, that's going to melt this ice at the margins and probably cause like a feedback loop as it warms up and melt more ice. The demise of a West Antarctic glacier poses the world's biggest threat to raise sea levels before 2100, and an ice shelf that's holding it back from the sea could collapse within 3 to 5 years. So about the time that you guys are in college, scientists reported December 13th at the American Geophysical Union's meeting in New Orleans. Thwaites Glacier is one of the largest, highest glaciers in Antarctica. It's huge. Ted Scambos, a glaciologist at Boulder, Colorado-based Cooperative Institute for Research in Environmental Sciences, told reporters. I highlighted this part because it's probably what everybody wants to know. Spanning 120 kilometers across, the glacier is roughly the size of Florida. And were the whole thing to fall into the ocean, probably going to happen in a few years, it would raise sea levels by 65 centimeters, more than 2 feet. Probably especially pertinent to us living in Florida, a low-lying flat state. Right now, its melting is responsible for about 4% of global sea level rise. But a large portion of the glacier is about to lose its tenuous grip on the sea floor, and that will dramatically speed up its seaward slide, the researcher said. That feedback loop I was talking about. Since about 2004, the eastern third of Thwaites has been braced by a floating ice shelf, an extension of the glacier that juts out into the sea. Right now, the underbelly of that shelf is lodged against an underwater mountain that's located about 50 kilometers offshore. That pinning point is essentially helping to hold the whole mass of ice into place. Data collected by the researchers beneath and around the shelf in the last 2 years suggests that brace won't hold much longer. Warm ocean waters are inexorably eating away at the ice from below. As the glacier's ice shelf loses mass, it's retreating inland and will eventually retreat completely behind the underwater mountain, pinning it in place. Meanwhile, fractures and crevices widened by these waters are swiftly snaking through the ice like cracks in a car's windshield, shattering and weakening it. This deadly punch jab uppercut combination of melting from below, ice shattering and losing its grip on the pinning point is pushing the ice shelf to imminent collapse. Within as little as 3 to 5 years, Aaron Pettit, a glaciologist at Oregon State University and Valley, and collapse of this ice shelf will result in a direct increase in sea level rise pretty rapidly. Pettit added, it's a bit unsettling because after it breaks off, probably float around a bit and take some time to melt. Let me skip a few paragraphs here. Ooh, got this fun looking picture. See the caption here. To better understand the rapid retreat of Thwaites Glacier, scientists drilled a hole through the ice at the glacier's grounding zone, the region where the land-based glacier juts out into the sea to become a floating ice shelf. Heated, sorry, this is an awkward place captured. Heater shown here. So heated water carved a borehole down through the ice to the grounding zone, allowing scientists to take the first ever measurements of ocean conditions in this region. So they're sitting at a place where maybe there's ocean down beneath this part of the ice shelf, this glacier. Right? These are machines that are drilling those boreholes, and the way they're doing that is by sending down heated water. So they can grab this data. As Thwaites and other glaciers retreat inland, some scientists have pondered whether they might form very tall cliffs of ice along the edge of the ocean, and the potential tumble of such massive blocks of ice into the sea could lead to devastatingly rapid sea level rise, a hypothesis known as marine ice cliff instability. How likely the researchers say such a collapse is depends on our understanding of the physics and dynamics of ice behavior, something about which scientists have historically known very little. The Thwaites collaboration is also tackling this problem. Right, so a couple paragraphs to conclude that, but yeah, there you go. So it looks like this ice shelf is probably about to collapse, saying maybe within about 5 years, but they don't know for sure. That involves some physics that don't have a complete understanding about, but it's going to happen sometime. A simple retina scan could predict your risk of early death. Oh, top Reddit comment. Goody, progress on death clock technology. Because, hey, if you could have like some machine that could like somehow say like, oh, you've got like 15 years left to live. This is actually probably the closest we've gotten to that, right? Just scan the back of your eye, your retina, so probably tell you something pretty close to that. Those with a large gap between measured retinal age and chronological age were more likely to die early. A new study has proposed that a simple retina scan could indicate whether a person is at risk of early death. The research found the greater the gap between a person's chronological age and retinal age, the higher risk of dying. Right? So if I say, how old are you? You say, okay, well, I know when I was born, I know what year it is, the difference is your age. Well, that's chronological age, right? But what about like your biological age? What they're saying retinal age, right? Something to do with like a direct measurement about how your body is aging. For example, if you smoke a bunch of cigarettes, you're going to age pretty quickly, right? Something like that, right? You'll look older. So plenty of people can act much more youthful than you expect from their chronological age. Others seem older than their years. Researchers have long suggested measuring a person's biological age could offer insight into their risk for many diseases, because a lot of these develop as you get older. But the challenge has been finding a simple measure to objectively track how fast the body is aging. And now they've got one, just scan your retina. One recent study honed in on a pattern of blood-based inflammatory biomarkers to measure a person's immune system age. Another project is tracking accumulation of DNA mutations over time as a way of calculating biological age. Okay? So get a DNA sample and determining potential lifespan. This latest method is perhaps the simplest to date, relying on an easy retinal scan to evaluate a person's biological age. The researchers used machine learning to create deep learning model designed to predict a person's age by measuring deterioration of tissues in the back of the eye. Pause right here. You guys see this about machine learning? You guys, quick story. Back when I was in elementary school in 1997, there was a machine that beat a chess grandmaster at chess for the first time in history. And how did that happen? Did they have some chess grandmaster like program into the computer, like the best way to play chess? No. What they did was they taught a computer how to play chess, and they had it play against itself internally, and then through a trial and error method, kind of a similar process to evolution, the computer figured out what the best chess moves were, and it got so good that it could even beat chess grandmasters. Right now, people can't beat computers. Computers are always going to beat people at chess, even the very best chess players in the world. Since then, machine learning has been used for all other kinds of applications, just things you would never even expect, including this. It somehow has a tie-in to this retinal scan. Oh, so it's about ring, isn't it? Okay, well, I'll have to call that a wrap then. So we got through most of those articles. Hope you guys enjoyed those, got something out of those. Remember, bring me your quiz on Monday, and yeah, that's a wrap on the week.